Welcome to Study Loop.
All right, for this problem, at least in part A, all we have to do is write the equation and put in P equals 0.05 and R is 3. So P, this is the equation, equals, I don't think it liked me using just regular R, so I'm going to call this R1. P equals 1 minus 10 to the negative P R1 squared power over PR1 squared times the natural log of 10. So the question is, what's the percent luminance sensed? Well, that would be 62%. So if we multiply by 100, that'll give the percent exactly. Okay, what's the percent luminance for a radius of 2? Well, then all I have to do is change the radius here to 2, and it's going to be 80%. Does it make sense that it's larger? Well, I would think that a 2 millimeter radius is going to need more light. So no, it doesn't make sense to me. And just like they observed that the amount of luminance was not proportional to the area of the pupil, it's inverse. So that seems counterintuitive. What's the limit as R goes to 0 from the plus side of P? So this is P. When R goes to 0, we're going to get P equals R goes to 0. Well, as R goes to 0, the denominator becomes 0, and then that's not good. So I'm going to take the derivative of the numerator and the denominator. The derivative of the numerator is negative 10. So let me write this down. It's going to be this. Copy that, put that here. So that's, and I'm still trying to just do the numerator. So let me see if oops, that didn't work. Okay. I wanted to put that negative up here. Okay, so it'll be itself times the derivative of the inside with respect to R, which would be negative P negative 2P R1. Now, I need to think about something here. All right, since this was base 10, I also have to multiply by the natural log of 10. Okay, so that's what I get, except the negative goes away. So let's think about this again. Bring this down. So it's going to be negative 10 to the negative P R1 squared times the natural log of 10. And then I need to multiply that by the derivative of the inside, which would be negative 2PR1. So a negative times negative is a positive. Good, got it. Now the denominator is going to be 2P R1, 2p R1, good, times the natural log of 10. Of course, the natural log of 10 cancels out, but nevertheless, now can we get r equals 0 into there? And no, we can't. Okay, so let's simplify this. 2 natural log of 10 times r1, r times p, cancels out in both the numerator and the denominator. So now I'm going to have to take the derivative again. This is not p, but it's the derivative of p, so I'm just going to do that. Okay, so now I'm going to take the derivative again. The derivative of the denominator is 1. The derivative of the numerator is the derivative of the first, which is 1, times the second. I'm just going to copy this. Derivative of the first times the second, plus derivative of the second times the first. So that would be r1, that's the first, times the derivative of the second, which would be that, times natural log of 10. So I'm going to put that in here. Okay. Times the derivative of the inside. So that's going to turn this to a negative, and that's going to make this derivative of the inside would be 2pr. That's going to give me an r squared on the outside. Okay. Now I can put r1 equals 0 into this. So 10 to the 0 power is 1 minus 2pr1 is 0 times natural log of 10 times 1. Okay, it's 1. And so, does this make sense? Yes, because the derivative or the limit as r goes to 0 is 1, which would be 100%. So as the whole size goes to 0, the luminance tends towards 100%. So, considering what I've learned, then yes, I would expect it to go toward 100%. Thank you for watching.